So hello friends, our today's question is question number 509, which is Fibonacci number. So this is a very famous question. Fibonacci number is a very famous number. What Fibonacci number is? Let's read question. So the Fibonacci numbers, commonly denoted as f of n, form a sequence called the Fibonacci sequence. So what's the Fibonacci sequence? Such that each number is the sum of two preceding ones, starting from 0 and 1. That is, so f of 0 will be 0 and f of 1 will be 1. These first two elements are fixed. Now the third element will be f of n will be f of n minus 1 plus f of n minus 2 for n greater than 1. So what this function is saying to us is, this function is basically for Fibonacci number. So Fibonacci number is denoted by f of n. So what is f of n? F of n is f of n minus 1 plus f of n minus 2. So uh, let's say I want to find an nth number. So nth number will be sum of the previous two numbers, which will be n minus 1th number and n minus 2th number. So given n, calculate f of n. So let's read the example. So for n equals to 2, our f of 2 will be f of 1 plus f of 0, which are fixed. We know that, and f of 1 is 1 and f of 0 is 0. So answer will be 1. So now we need to find n equals to 3. So we can do this by f of 3 is f of 2 plus f of 1. F of 1 we know, and f of 2 we will find by f of 1 plus f of 0, which is found in the previous question. So it will be 2. Now n is equals to 4, so n f of 4 will be f of 3 plus f of 2. F of 3 we have here, and f of 2 is also here. So 2 plus 1, which is equal to 3. So how we will approach this question? By reading this question, I can see that is, we need a line that will calculate this function. Like we need this line, we need that type of line which calculates these two and add up and continues till the condition is achieved, and then the loop stops. So I will not use loop here, I will use recursion concept here. So what recursion concept is? So let's understand. Now we know first two elements, so we know that f of 0 is 0 and f of 1 is also 1. So we know that these first two elements are fixed. Now we need to find f of 2. So how we will find f of 2? So we know the general formula of this question is f of n is f of n minus 1 plus f of n minus 2. So how we need to achieve this by recursion. So if we need to find f of 2, if we put n equals to 2 in this formula, so it becomes f of 1 plus f of 0, which we know that is equal to 1. Now we need to find f of 3, so it will be f of 2 plus f of 1, so it will be 2 here. Now we need to find f of 4, so it will be f of 3 plus f of 2. So f of 3 is 2 and f of 2 is 1, so it will be 3 here. So this continues till f of n. This will continue till f of n. And now what we need to check? So we can do one thing, like in recursion, first step will be the base case. There will be two base cases. First will be if n is 0, so we will return 1 when the number is 0, when the input is 0 basically. So our first number is 0, so we will return n 0. And the second base case is if n is 1, so we will return here 1. Now the main concept, the base case is done. Now we need to run loop basically by writing one line. So how we'll do this? So we will just do, now we need to return it. So how we will return it? Like if we want this, so we will do, like we have fib function here, as you can see here, we have fib function here. So fib of n minus 1 plus fib of, we will write just fib of n minus 2, and it's done. So our base case is also done, and our loop is also done, which will continuously run until the n is achieved here. N is 0 or 1 achieved here. After n is 1 or 0, the this whole code will completely finished and the output will be given. So let's take an example. So I am taking n equals to 6. For n equals to 6, we know that it will calculate this. So we will have here fib of 5 plus fib of n minus 2 is 4. Now this will continue till now we need to find this fib of 5. So for fib of 5 we, be, we will have fib of 4 plus fib of 3. Now for f of fib of 4 there will be fib of 3 plus fib of 2. Now for a fib of 3 will be fib of 2 plus fib of 1. Now for fib of 2 we will have fib of 1 plus fib of 0. So until these two condition has reached, now we know that fib of 1 in our if condition we have n equals to 1, so 1. So here will be 1 plus 0 which will be 1. Now we will go here, if the code will execute here, so our fib of 2 will be 1. We know that fib of 1 is 1, so it will be 2. Now the code will execute here, so fib of 3, we know fib of 2, and fib of 3 we have. What is fib of 3? Fib of 3 is fib of 2 plus fib of 1. So we have fib of 3 here, so 2 plus fib of 2. Fib of 2 is 1. So now fib of 4 will be this. So the code is executed here. We know that fib of 4 is 3. Now fib of 3 is what? Fib of 3 is 2. So 3 plus 2 which will be 5. Now we know that this is 5 and fib of 5 is this only. So what is fib of 5? 5 plus 2 which is 7. So our final output will be 6. Now we will do code. Now first we need to write two base cases, which will be if n equals to 0 we will return 0. Now if n is equal to 1, so we will return 1. Now the last line to run loop is fib of n minus 1 plus fib of n minus 2. Now let's run this question. Okay, as you can see here, all the test cases are passed perfectly. Now let's submit it and check the results. So as you can see here, it is accepted and all the test cases are passed perfectly. Our runtime is 14 millisecond and beats are 21.55%. Memory used here is 7.65 MB and beats are 88.07%. And this was the solution of this question by recursion concept. Thank you.